Hi everyone, Mrs. Quinville here to kick off our Unit 8 Equations and Inequalities unit for our 6th grade math curriculum. Here we have Student Handout 1, Combining Like Terms. We're going to talk about how like terms are terms that have the same variable raised to the same power or no variable at all, which we call constants or just regular numbers. These can be whole numbers, fractions, or decimals, otherwise known as rational numbers. The other thing we mentioned back in class way last week when we were in there, was that when we're combining like terms, it's like putting categories of things together. So for example, maybe sticks or rocks, they would be in their own category. Legos or blocks would be in their own category. The ones, tens, hundreds, when we looked at the number cubes, they had their own category. Okay, so that's what we're talking about here. So if you look at the top of this, we have it says group the like items together and determine how many of each there are. So if you count out the popcorns, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 popcorns. How many movie boards are there? 1, 2, 3, 4. So we would write the number 4 here next to the movie board. Below that, we have some fill in the blanks. So algebraic terms can be combined in a similar manner. So when we're talking about an algebraic term, we're talking about a term that has a variable, okay? You would go around the world counting things and keeping them in their own categories. Algebraic terms just have a variable, which is some unknown value. We stick a letter there. They can also be raised to powers. Like instead of just x, we could have x squared. X squared is a different variable term because it's raised to a different power, okay? So a term is considered like if it has the same variable, please write in the word variable, with the same power or exponent. I used to say that the y term, like the y variable, is just a regular yo-yo. Y squared would be like a yo-yo that glows. Or y to the third power, even cooler, a yo-yo with no string, right? So they're just different categories or like different powers. And then below that, constants or numbers can also be combined with each other. So these are just regular old constant numbers. A constant is a number that we know the value of. It's not going to change. It's just something that we already know. Just like when you're adding 2 plus 2 or 5 minus 3, those can be combined. And of course, fractions and decimals can also be combined, just like constants. So below that, it says use a different shape or color to group the like terms together and explain your thinking. So I went ahead and made some different shapes and colors for these terms. So notice all the X's. I used my lovely purple marker and put boxes around all of the X's. So I have a purple box. We have an 11X, a 7X, a 4X, a 5X. Those are all the same term, which means they can be combined. Now I only have one x squared term, but there's a 3 in front of it, so the coefficient is 3. That means there are 3 x squared terms. Then I use my pink marker for the y's. So I have 13y, 9y, 12y, 15y. All of those y's can be combined. And my constants I circled with a green. You'll notice my hands are like heavily dyed. It's all purple marker. Don't worry, it'll wash off because I'm washing my hands like crazy. All right, so below here, I have 3x squared. So how many x squared terms are there? There are 3 of them. I know that by the coefficient. For the x's, there's 11 plus 7, so that's 18x. We can add the coefficients. Plus 4, so 18 plus 4, 22, plus 5x, that's 27x terms. And then for the y's, 13 plus 9 plus 12 plus 15 altogether is 49 y terms. For the constants, it's just like basic addition. 1 plus 24, 25, plus 15, plus 3, plus 8, for a total of 51 constant terms. So please go ahead and fill in those. We have 3x squared, 27x, 49y, 51 constants. That's all we can do. So if we were to write that out as an expression, it would read 3x squared plus 27x plus 49y plus 51. So expressions, we can simplify them, we can combine like terms, we can't solve them. We don't know what x squared value is. We don't know what x is. We don't know what y is representing or stands for. Okay, so if we don't know the value of something, all we can do is simplify it. Below that, practice simplifying expressions by combining the like terms. So here, notice again, I've tried to color code it to make it a little easier to look at. So the 16x plus 12x all together is 18x. Again, we're adding the coefficient. The coefficient's the number in front of the variable. So 6 plus 12 is 18, and you keep the x term. And then there's just 13y left over. So you just bring that down. So the simplified expression is 18x plus 3y. That is the answer. You cannot combine the x's and the y's together. You cannot add 18 plus 3. This is the simplified expression. If we were told to evaluate when x equals 2 and y equals 5, then we could multiply 18 times 2, which is 36, plus 3 times 5, which is 15, add those together and find an answer. But we don't know that. We're literally just simplifying it, so this is the answer. 18x plus 3y is the answer to this algebraic expression. We have simplified it. We are done. Over here, we have 11y, just bring that down, and then 5 plus 9 are constants that can be combined. So the answer is 11y plus 14. For number 3, we're given 6x plus 2y. Notice I have a purple boxed out 6x, and then I have like a pink cloud of 2y. They're totally different terms. They cannot be combined. So this is the answer. Number 3 was sort of like a trick question because it's already simplified. For 4, we are given 15x plus 9x. So we add the 15 plus the 9. I would highly recommend that you all color code these at home, box them out, shape them out. You can use like a little line to show that they can be combined. Keep it simple for you. Okay, so we have 15x plus 9x simplifies to 24x's all together. And then the 19 is just a leftover. It's a constant term that's left over. You can't do anything with it. So it's just 14x plus 19. For number 5, I have 3 pink clouds. So they are all the same term. I have 10y plus 6y plus 8y. 10 plus 6 plus 8 simplifies to 24y. So 24y is the final answer. That is the simplified expression. All those y's can be combined. And then finally for number 6 on this side, we have 8x squared plus 10x. The 8x squared is its own term. That's why it's in this blue pentagon shape. And then the 10x is also its own term. So I have 8x squareds plus 10x. Even though they're both the letter x, they are different terms. They cannot be combined. This is a regular old x, this is an x squared. So they have to stay separate. They cannot be combined. Remember, the definition of a like term is a term raised to the same power, or a term with the same variable raised to the same power, or no variable at all. So an example of a term with no variable at all is just your constant term, right? All these regular old numbers that you're used to working with. And again, those can include fractions and decimals. So I'm going to go ahead and turn the page. All right, so here at the top, we have subtracting like terms. Just like we combined with addition, you can do the same with subtraction. Okay, so like terms can be subtracted, but remember to keep the sign as a part of the term. So use the rules for integer operations as you combine terms. So notice here we have 6c minus 5c. Well, 6 minus 5 equals just 1. Note, you will typically only see it as the letter c. Okay, this is like an invisible coefficient. If you only have one c, you would just write the letter C. Just like when I introduced myself back to you all in September, I said, hi, I'm Mrs. Quinville. I didn't say, hi, I'm one Mrs. Quinville. Same is true here for variables. And then we have 13c minus 5c, which simplifies to 8c. We're just subtracting the coefficient. So 13 minus 5 is 8. Below that, you'll notice that I marked off, again, with shapes and colors. So we have 14x minus 8x simplifies to 6x. There are no other y terms to combine with, so you just bring down the 3y. So 6x plus 3y is the answer. Over here, we have 16x plus 5x. That simplifies to 21x. And then you bring down the minus 9. Here it says practice simplifying expressions by combining the like terms below. So we have 11d plus, I'm sorry, that's an a. 11a plus 3a simplifies to 14a, and then you bring down the minus 5c. The a and the c, totally different terms, they cannot be combined. So final answer is 14a minus 5c. For number 8, you have 12b minus 7b, simplify those first, to be 5b. Here's a 16 that's just left over. You bring it down. Notice if there's no sign, we assume for it to be positive. This is just 5b plus 16. Another way to write this expression, an equivalent expression would be 16 plus 5b. You can use commutative property of addition to flip those and have it be the same value. Over here, 4d minus 3d simplifies to just d minus 8. You could write 1d minus 8, but algebraically, it'll just get even simpler to just the letter D. We know this is 1D. We have an invisible 1 in front of that, okay? Down here, we've got 21g minus 8g. If you're having trouble with the variables, think of it as like groups of giraffes. So 21 groups of giraffes minus 8 groups of giraffes would leave 13 groups of giraffes. So 13g, bring down the minus 6f. Over here we have 6t minus 2t combined to make 4t. And then in the pink, 19s minus 10s would just be 9s. So 4t plus 9s, which is equivalent to 9s plus 4t. So you could write this either way. And here's one that I left to do with you. So if we have 18r, here's my r's, and then 11 minus 11r. So we're doing 18 minus 11, which would just give us 7r. And then we have 7q plus 13q. So you can go ahead and box that off, circle it, whatever you want to do to recognize that it's different than the r's. So we're doing 13 plus 7, which is 20. So we would write in 20q and bring down the sign. The sign goes with the terms. Notice that I circled it here. Otherwise, I would have just assumed to add it. But this literally means 18r minus 11r, which simplifies to 7r. You could think of it as 18 groups of robots. I say groups because we don't know the value of r. So it's really not just 18 robots. If that's easier to think of for now, you can do that. So 18r minus 11r is 7r, and then combine the q's, so plus 20q. Below here, for number 13, look at these greens. First, it looks tricky, but we have 12, a positive 12, and then we have a negative 4 and a negative 8. So those combine to make a negative 12. Think of it as you spent $4 and you spent $8 more. You've spent a total of $12. So this simplifies to 12 minus 12, which is just 0. So you just bring down the 12w, and that is the answer. 12w simplifies the expression. And notice too, this is an additive inverse. So 12 and negative 12, or negative 12 plus 12, they would all cancel out and equal 0. They are opposites. For number 14, we have all d's. So 15d plus 3d minus 7d minus 1d. I would combine these first. So this is negative 7 and a negative 1d simplifies to negative 8d. So we have 18d's minus 8d's is just 10d, okay? For number 15, we have some x squareds together. So 4x squared minus, or I'm sorry, 4x squared plus 14x plus, well, when you add them together, you get 18x squared. And then I forgot to bring this down earlier. So we have 18x squared in the blue, and then the minus x below there. We're now taking this to the next level. So we're looking at what we've learned with combining like terms and applying it to geometry, which is our next unit. So for here, We're looking at perimeter. The directions say write an expression to represent the perimeter of each figure below. So we have an equilateral triangle. This is 15x plus 2.5. If this side is 15x plus 2.5, then this side is also 15x plus 2.5. And this side is 15x plus 2.5. So you can use the perimeter formula, which in this case would be perimeter is equal to side plus side plus side, or 3 times the side. So here we can use distributive property. Perimeter is equal to 3, because there's 3 sides, times 15x plus 2.5, because the measurement of one side is 15x plus 2.5. So we're going to use what we learned in the last unit with distributive property. 3 times 15, again, we're multiplying the coefficients, is 45. So 3 times 15x is 45x, and then 3 times 2.5 is 7.5. So the entire perimeter of this equilateral triangle in the simplification of this algebraic expression is just 45x plus 7.5. Of course, you also could have just added these. You could have done 15x plus 15x plus 15x and still gotten 45x. And then 2.5 plus 2.5 is 5, plus another 2.5 is 7.5. So whatever is easier for you right now, you can do that. You could have just done side plus side plus side, or could have seen you could have simplified it to distributive property and then gotten 45x plus 7.5. For the very last one, 17, you're just adding up all the sides and combining the like terms. So you have 3x plus 3x plus 3x plus 2x. So 3 plus 3 is 6, plus 3 is 9, plus 2 is 11. So there's the 11x. And then we have 8 plus 4 is 12. So there's the 12. Minus 1 would be 11, minus another one is 10. So the entire perimeter of this trapezoid is 11x plus 10. And that's it. So to summarize today's lesson, we learned that only like terms can be combined to simplify an algebraic expression. And again, we know that a like term is a term with the same variable raised to the same power or no variable at all. Okay, so when you finish taking these notes, please try the homework. I will post that as a separate video. Also note that you can pause the video if I went too fast. Thank you guys. I'll talk to you later. Bye.